A very good morning to all of you, my dear students. A very good morning to all everyone. Just फटाफट से बता दीजिए whether the audio and video is clear or not. Just tell me whether the audio and video is clear or not. If the audio and video is clear, then we can start our session. If the audio and video is clear, then we can start our session. चलिए, सब कुछ ठीक है, अपने सेशन को स्टार्ट करते हैं. So let's start our session. Crack ESE Assistant Engineer Examination, Junior Engineer Examination with India's largest online live learning platform, that is Unacademy. Unacademy का प्लस सब्सक्रिप्शन ले सकते हैं. Unacademy का प्लस और आइकॉनिक सब्सक्रिप्शन लेकर you will get an unlimited access to live and recorded courses from India's best educators. अगर आप मेरे बारे में जानना चाहते हैं तो मेरा नाम है बेटा मोहम्मद एहतिशाम सिद्दीकी. आई एम alumni of JMI New Delhi, 4 times GATE qualified, 3.5 years of teaching experience, taught more than 10,000 students all over the India, guided students who secured AIR rank 1 in the different examinations: geotechnical engineering, water resource engineering, environmental engineering, structure analysis, surveying, construction planning and management, RCC और स्टील. दीज आर द सब्जेक्ट्स जो कि मैं अनअकैडमी की ऐप और अनअकैडमी की लर्निंग ऐप पर पढ़ाता हूँ. मूविंग फॉरवर्ड, अगर आप प्लस सब्सक्रिप्शन लेना चाहते हैं, है ना, तो आपको डेली लाइव क्लासेस मिलती है, लाइव टेस्ट एंड क्विजेस मिलते हैं, स्ट्रक्चर्ड कोर्सेस मिलते हैं. यू विल गेट अनलिमिटेड एक्सेस टू द रिकॉर्डेड कोर्सेस. If you want an iconic subscription, you will get a personal coach, you will get means question answer practice, study tracker, and you will get all the benefits of plus subscription. You will learn from the top educators like Marun Tiwari sir, Ankit Goyal sir, Sanjit Jain sir, Jaspal Singh sir. Moving forward, these are the plans of plus. These are the plus plans. You can adopt any plan for your preparations depending upon that how much time you're left for your preparations. So if you want to take 1 month plan, then the fees cost around 5,500. And if you want to take 24 months plan, the fees cost around 44,000. You don't have to need to pay 44,000 or 5,500 rupees. You just have to be put a referral code named with ES001. This is my referral code. When you enter this referral code, you will get an instant 10% discount. You will get an instant 10% discount. The 44,000 rupees plan, which is of 24 months, will cost only 39,600 rupees. So all you need to enter this magical code. When you enter this magical code, you will get 10% discount. Moving forward, if you want to take the iconic subscription, then there are two plans. One plan is of 50,250, and this another plan which is of 24 months, it is of 74,000. But if you use my code named with ES001, if you use my code named with ES001, you will get instant 10% discount. You will get instant 10% discount. So suppose the fees of the 1 year plan is 50,250, but if you use my code, then the fees only will cost around 45,225. Moving forward, if any of your brother, any of your sister, any of your friend, any of your relative preparing for GATE, ESE, SSC, APPSC, MPPSC, MPSC, GRE, IIT, NEET, CAT, UPSC, Civil Services Examination, NET, NEET, IIT, CLAT, NET, IELTS, any examination, just enter my code ES001. On all the examination, though, that student will get a discount. Further, if you have any queries regarding the plus subscription, regarding the notes, regarding the doubts which come after the class, regarding the practice papers, regarding other things, then you can contact me by clicking Civil by Siddiqui sir on the Telegram. When you enter Civil by Siddiqui sir on the Telegram, a a telegram will appear named with Siddiqui Sir Unacademy. You just have to be enter that that group and just start learning or getting, or you can message me anytime on the telegram. Okay, moving forward, in today's class, okay, this is India's largest fortnightly competition, which is called as combat, which is already conducted on 24 March. If you want to more combat sessions, stay tuned. The next date for the combat will be coming very soon. So most important one liners of soil mechanics, we are discussing about important one liners. I'm really sorry for the classes. मैं मेरी तबीयत अभी from the last 3 or 4 days my health is not good. जब से I came to Delhi मेरी तबीयत ठीक नहीं है, इस वजह से थोड़ा सा इश्यूज आ पा रहे हैं क्लास में, लेकिन मैं कोशिश पूरी करूंगा. आई एम जस्ट टोटली एग्जॉस्टेड, मतलब एग्जॉस्टेड इन सेंस जैसे एक मतलब बहुत ज्यादा फीवर आने के बाद जो एक आप अंदर से बहुत ही ज्यादा वीक फील करते हैं, फीलिंग लाइक दिस. तो यू डोंट हैव टू बी वरी अबाउट इट, एंड आई एम रियली सॉरी दैट क्लास थोड़ी बहुत लेट हो जाती है तो उसके लिए. तो हम लोगों ने लास्ट क्लास में क्या किया था, कई सारे हम लोगों ने बेटा वन लाइनर्स कर रखे थे up to question number 25, I think. Up to question number 25 we have done the one liners. So let's start the one liners from the question number 26. Let's start the one liners with the question number 26. This is the very first question. This question is all about if the degree of saturation is 60, 0.6, then the soil is humid. If the degree of saturation is 0.6, then the soil is humid. You need to have to be tell whether this statement is true or false. You need to tell whether this statement is true or false. Whether this statement is true or false. When the degree of saturation is 60%, then he is saying the soil is humid. You just have to be you just need to tell whether this statement is true or false. And kindly share this class with all of your students, because all of the students will get benefit with this class. All of the students will get benefit with the class, and if you share this class, then only it is possible. So if I talk about that whether this statement is true and false, so here I'm writing the nature of soil. You need to remember one table. Here I'm writing the nature of soil, and here I'm writing DH. Here I'm writing DH, DM, DH, DM, DH, DM, DH, DM, WF. DH, DM, WF. And here I'm writing the degree of saturation. Here I'm writing the degree of saturation. Nature of soil, and here I'm writing the degree of saturation. So if the nature of soil is dry, then the degree of D for dry. If the nature of the soil is dry, then the degree of saturation is 0. If the degree of saturation lies between 0 to 0.25, 0 to 0.25, then the nature of soil is said to be humid. If the degree of saturation lies between 0.25 to 0.50, then the nature of the soil is damp. If the degree of saturation lies between 0.50 to 0.75, then the nature of the soil is said to be moist. If the degree of saturation lies between 0.75 to 1, then the nature of the soil is said to be wet. And if the degree of saturation is exactly 1, then the soil is said to be fully saturated. Now in this question, he is saying if the degree of saturation is 60%. 60% means if the degree of saturation is 60%, it means, my dear students, if the degree of saturation is 60%, it will lies between 0.5 to 0.75 means the soil is said to be moist. So this statement will be wrong, and the answer of question number 26 will be B. Answer of question number 26 will be B. Moving forward, question number 27. This is question number 27. For all types of soil, temperature of the oven is 105 to 110 degrees Celsius. Tell me whether this statement is true and false. So for all types of soil, कई सारे students, let me check. Now for all types of soils, the temperature of the oven is 105 degrees Celsius. This statement is absolutely false, because for all types of soil, the temperature is not lies between 105 to 110 degrees Celsius. For if I talk about for inorganic soils, temperature lies between 105 degrees Celsius to 110 degree Celsius. But if I ask for the organic soils, if I talk about the organic soils, or soil containing gypsum content, then the temperature lies between 60 degrees Celsius to 80 degrees. What he is trying to say, for all types of soil, the temperature lies between 105 से 110 डिग्री सेल्सियस. ये स्टेटमेंट क्या हो जाएगा आपका? This statement is absolutely false. This statement is also false. The correct answer of this question would be, इस क्वेश्चन का आंसर भी हो जाएगा आपका B. Moving forward, question number 28. Question number 28. Just read it, this question. As the coarser particles are mixed in the soil, the value of OMC increase, but the maximum dry density decreases. Just listen. When we add some coarser particles, in any soil, then what happens? The specific surface area of that soil will get decreases. If the specific surface area will get decreases, then the soil needs less amount of water to lubricate its particle. And if the less amount of water is required to lubricate its particle, then it means that the higher gamma D will be obtained. So when you add the coarser particles to the soil, the specific surface area will get decreases, OMC will automatically decreases, and if the OMC will get decreases, then the maximum dry density gamma D maximum will get increases. Maximum dry density gamma D maximum will get increases. The correct answer of this question would be, he is saying that the OMC will increase but the maximum dry density will decrease. But actually when we add the coarser particles to the soil, then the OMC will get decreases and the maximum dry density will get increases. So this statement, question number 22, is also false. This statement is absolutely false. Moving forward, this is the question number 29. Moving forward, this is all about the question number 29. Tell me the answer of question number 29. Moving forward, and just tell me the question number 29. What will be the answer of question number 29? Silty gravel have a higher maximum dry density as compared to silty sand at same compaction energy. This is a beautiful question. Just tell it. Silty gravel has a higher maximum dry density as compared to silty sand. So there are two types of soil. One is silty gravel, that is silty gravel means GM, and another is called as silty sand. Silty sand means SM. There are two types of soil. One is GM and another is SM. So if you apply the same compaction energy to both the soils, if you apply the same compaction energy, if you apply the same compaction energy, my dear students, if you apply the same compaction energy to both the soils. So if I talk about that both of the soils, which soil have higher specific surface area? So you will say the specific surface area of the as silty sand is greater than specific surface area is greater than specific surface area of GM. The specific surface area of SM is greater than specific surface area of GM. So if the specific surface area of SM is more, then the more water is required, in order to lubricate the surface of the SM. So if more water is required, so definitely the optimum moisture content of silty sand is much greater than the optimum moisture content of silty gravel. So if the optimum moisture content of the sand is more, then definitely if the optimum moisture content is more, you have written the formula that gamma D maximum, you know the formula, gamma D maximum is equal to GS gamma W divided by 1 plus OMC, 1 plus OMC, GS gamma W upon 1 plus E को क्या लिख सकते हैं, W into GS divided by E. Here, if the OMC of any soil is more, then the gamma D obtained would be less. Even at same compaction energy. तो यहाँ से obvious सी बात है, gamma D maximum of SM, gamma D maximum of SM is less than gamma D maximum of GM. So what he is saying that the silty gravel have a higher dry density as compared to silty sand. This statement is absolutely true. This statement is absolutely true. The right answer of this question would be 29 का A हो जाएगा. Very good afternoon. Very good afternoon. Very good morning. जैसा भी आप. So question number 29 का आंसर हो जाएगा बेटा A. A is absolutely true. Moving forward, question number 30. Tell me the answer of question number 30. Tell me the answer of question number 30. Capillary rise in the water depends upon the effective size, depends upon the void ratio, and the past stress history of the soil. Depending upon the effective size, void ratio, and the past history of the soil. Just tell me of this answer of this question. Abhishek is saying that this statement is true. Okay, so as we know, the capillary rise is the complex function of the soil voids which are interconnected in the soil. So this HC can be determined by 0.0, 0.2, can be determined by 0.2, 0.03 divided by 0.2 times of D10, or it can also be determined by SC is equal to C upon E into D10. C upon E into D10. So here what you are saying that the capillary rise depends upon the void ratio. Capillary rise depends upon the effective size, and also the capillary rise depends upon the past history. So this statement is absolutely true. So the right answer of question number 30 would be A. Very good. The right answer of question number 30 would be A. Moving forward, tell me the answer of question number 31. Tell me the answer of question number 31. So what he's trying to say, effective stress is also called as intragranular stress. This statement is absolutely this statement is absolutely false, because if I talk about the intergranular stress, if I talk about the intergranular stress, if I talk about the intergranular stress, what is intergranular stress? The sum of forces transferred through grain to grain contact area. The sum of forces transfers through grain to grain contact in the normal direction divided by grain contact area. If I talk about the intergranular stresses, then it is the sum of forces through passes through grain to grain contact divided by grain contact area is called as intragranular stresses. Okay, but according to Terzaghi, the effective stress was defined as, the effective stress according to Terzaghi, the stress was designed as summation of normal forces transfers through grain contact, summation of normal forces transfers through grain contact divided by total area. So if you see the first statement, it has certain physical meaning, that intragranular stress is equal to summation of grain contact area divided by summation of forces transferred through grain contact area divided by grain contact area. बिकॉज ये बता रहा है कि सॉइल के द्वारा, सॉइल के वॉइड्स, सॉइल के सॉलिड्स के द्वारा, सॉइल के सॉलिड्स के कांटेक्ट के द्वारा कितने फोर्सेस ट्रांसफर हो रहे हैं। लेकिन इफेक्टिव स्ट्रेस को डिफाइन किया है कि नॉर्मल फोर्सेस कितने ट्रांसफर हो रहे हैं डिवाइडेड बाय टोटल एरिया। तो इसका तो कोई एक फिजिकल मीनिंग है, इसका कोई भी फिजिकल मीनिंग नहीं है, इसीलिए इफेक्टिव स्ट्रेस एक इमेजिनरी पैरामीटर है। और बेटा इंटरग्रेनुलर स्ट्रेस और इफेक्टिव स्ट्रेस की बात करें तो बेटा ग्रेन कांटेक्ट एरिया तो टोटल एरिया का इसकी तुलना में बहुत ज्यादा कम होता है। लगभग जो ग्रेन कांटेक्ट एरिया होता है वो टोटल एरिया का केवल 5% होता है। तो ग्रेन कांटेक्ट एरिया बहुत ज्यादा कम है एज कंपेयर टू टोटल एरिया। तो ऑब्वियस सी बात है इंट्राग्रेनुलर स्ट्रेसेस की वैल्यू बहुत ज्यादा मिलेगी एज कंपेयर टू इफेक्टिव स्ट्रेस। बहुत सारे लोग बेटा इफेक्टिव स्ट्रेस को इंट्राग्रेनुलर स्ट्रेसेस कहते हैं, लेकिन ये बात पूरी तरीके से यस इट इज लेकिन ये बात बहुत पूरी तरीके से गलत है। इट इज एज पर वाइटमैन। ओके, वेरी सही बोल रहे हैं, ये वाइटमैन के अकॉर्डिंग थी। लेकिन जब टरजागी बाबा आए तो टरजागी बाबा ने अपनी इफेक्टिव स्ट्रेस की डेफिनेशन को एक नई फॉर्म में शो किया। तो क्वेश्चन नंबर 31 का हो जाएगा आपका फॉल्स। इस क्वेश्चन का आंसर हो जाएगा फॉल्स, दैट इज बी। मूविंग फॉरवर्ड टू द क्वेश्चन नंबर 32, बताइए। मूविंग फॉरवर्ड टू द क्वेश्चन नंबर 32। बिल्कुल राइट, शशि इज एब्सोल्युटली राइट। This statement was true according to the Whiteman, but when the Terzaghi will came into field for the effective stress, Terzaghi have defined the effective stress in a better way. That's why this assumption of transferring the stresses through grain to grain contact called as effective stress was discarded. Yes, absolutely. Next, nice explanation. Nice explanation by Shashi. Okay, very good, Shashi. Moving forward to the question number 32, best soil for homogeneous rolled embankment. So best soil for homogeneous rolled embankment. What do you mean by homogeneous? What does it mean by homogeneous? It means that the soil is homogeneous throughout its cross section, throughout its length. What do you mean by rolled? What do you mean by rolled? It means that the dam is constructed by rolling, by doing the compaction. By rolling or by doing compaction of a homogeneous soil, we have constructed the dam called as homogeneous rolled earthen dam. So he is asking what is the best soil for the homogeneous rolled dam or rolled embankment, anything. So the best soil for this dam would be, just think, what is the purpose of dam? What is the purpose of dam? Just think about what is the purpose of dam. If I ask about what is the purpose of dam, then you say the purpose of dam to store the water. The purpose of dam is to store the water behind it. Matlab its purpose is to create a reservoir. Its purpose is to create a reservoir. So if you construct a reservoir, then it means that the height of the dam is sufficient. It means that the height of the dam is sufficient. So if you construct this dam, so what will happen? The water which is stored behind it, will apply a water pressure. Then it is necessary that this dam have sufficient strength. To resist this load. So in order to make a structure to have a sufficient strength, this soil should have sufficient strength. And as we know that the highest strength is of gravel, so we will use the gravel because of its high strength in order to resist the forces exerted by the water and other factors. But what happens if you simply use gravel? Then the voids created by gravel is very high. So the water will percolate from the upstream side to the downstream side. Yeah, exactly. So what will we do? We will add clay. Clay will go inside the voids of the gravel. It will just fill all the voids of gravel, and the water will does not start. So gravel will give the strength and the clay will decrease the permeability. So best soil for the homogeneous earthen dam is GC. Absolutely, Shashi, you have given the very good answer. Okay, great, Shashi, you have given the very right answer. Okay, moving forward to the question number 32. Moving forward to the question number 33. Tell me the answer of question number 33. Tell me the answer of question number 33. What is all about? When the actual hydraulic gradient is equal to critical hydraulic gradient, then the effective stress becomes zero. When the actual hydraulic gradient becomes equal to critical hydraulic gradient, then the effective stress in clay becomes is equal to zero. Whether this statement is true or false, Madhu Maurya is saying 33 का B. देखिए, जब आपका हाइड्रोलिक ग्रेडियंट, एक्चुअली हाइड्रोलिक ग्रेडियंट जब बेटा ICR के बराबर हो जाता है, जब एक्चुअल हाइड्रोलिक ग्रेडियंट ICR के बराबर हो जाता है, तब इफेक्टिव स्ट्रेस की वैल्यू जीरो हो जाती है. चाहे आपकी ये सैंड हो, और चाहे आपकी ये क्ले हो, दोनों केसेस में इफेक्टिव स्ट्रेस की वैल्यू जीरो हो जाती है. बट सैंड हैव जीरो कोहेजन, बट क्ले हैव सफिशिएंट कोहेजन. तो जिसके कारण अगर शेयर स्ट्रेंथ निकालेंगे तो शेयर स्ट्रेंथ होती है बेटा C प्लस सिग्मा बार 10 ऑफ 5. तो अगर सिग्मा बार जीरो हो गया, C की वैल्यू जीरो है, तो सैंड की शेयर स्ट्रेंथ जीरो हो जाती है और सैंड बेटा पानी के साथ फ्लो करना चालू कर जाती है. लेकिन क्ले की शेयर स्ट्रेंथ अभी भी बेटा कोहेजन के फॉर्म में है, तो क्ले के अंदर कोई सैंड कंडीशन नहीं होती. तो जब बेटा आप फ्लो, चाहे आप बेटा क्ले में पानी को फ्लो कराओ, चाहे सैंड में पानी को फ्लो कराओ, अगर आप पानी को क्रिटिकल हाइड्रोलिक ग्रेडियंट पर फ्लो कराएंगे तो दोनों के केस में इफेक्टिव स्ट्रेस की वैल्यू जीरो हो जाती है, सैंड के केस में भी और क्ले के केस में भी. सिंस सैंड हैव सर्टेन कोहेजन in the form clay have certain cohesion in the form of certain cohesive strength in the form of cohesion. That's why the clay does not show the quicksand condition, but the sand will shows the quicksand condition. This statement is absolutely true. Both the soils will be subjected to zero effective stress. I hope your concept will get cleared. Moving forward, yes, Shashi, your answer is right. But the Madhu Maurya, your answer is wrong. No issues. Moving forward to the question number 34. Tell me the answer of question number 34. So what he is trying to say, he is saying the flow net is the graphical solution of Laplace equation, which indicates how much hydraulic energy will lost when the water flows through a resisting medium. When the water will flows through the resisting medium, then how much energy will be lost? He is trying to ask. So the right answer of this question would be 34 ka A. Definitely, the flow net is basically the graphical solution of Laplace equation. And if I talk about what is Laplace equation, the Laplace equation is equal to del psi upon del x square plus del phi upon del y square is equal to 0. When this equation is Laplace equation, when you solve this Laplace equation graphically, when you solve this equation graphically, when you solve this equation graphically, then there are two sets of curve, then there two sets of curve are obtained, then two sets of curve will are called as two sets of curve may form a set of net that is called as flow net. उसको हम लोग बोलते हैं बेटा, उसको हम बोलते हैं that is called as flow net. यस, और वो फ्लो नेट ये बताता है, जैसे आपकी लैपलास इक्वेशन ये बताती है कितनी हाइड्रोलिक एनर्जी लॉस्ट होगी, उसी तरीके से ये जो फ्लो नेट है वो भी ये बताता है कि जब पानी एक रेसिस्टिंग मीडियम से फ्लो करता है तो उसकी कितनी हाइड्रोलिक एनर्जी लॉस्ट हो जाती है, उसकी कितनी हाइड्रोलिक एनर्जी आपकी लॉस्ट हो जाती है. क्लियर हो रही है बात? So I hope you understand about it, that the flow net is the graphical solution of the Laplace equation. So this statement is true. Moving forward to the question number 35. Moving forward to the question number 35. Tell me the answer of question number 35. Tell me the question number 35. So question number 35, when the number of flow lines, if the number of flow lines and the equipotential lines in the flow net are 14 and 28, then the shape factor is 0.5. So Madhu is 35 का B. देखते हैं जरा बेटा, शेप फैक्टर क्या होता है. अगर आप बेटा फ्लो नेट की मदद से डिस्चार्ज निकालते हैं तो Q होता है, Q इज इक्वल टू KH. इट इज इक्वल टू Q होता है बेटा, Q इज इक्वल टू KH. Q is equal to KH multiplied by NF upon ND. Q is equal to KH multiplied by NF upon ND. So this NF upon ND is called as shape factor. This NF upon ND is called as shape factor. So कह रहा है if the number of flow lines and number NF होता है number of flow channels, ND होता है number of equipotential drop. और नंबर ऑफ फ्लो चैनल्स किसके बराबर होते हैं, नंबर ऑफ फ्लो लाइंस -1, एंड नंबर ऑफ इक्विपोटेंशियल ड्रॉप इज इक्वल टू नंबर ऑफ इक्विपोटेंशियल लाइन -1। सो बेटा यहां से अगर आप शेप फैक्टर निकालेंगे SF, तो नंबर ऑफ फ्लो लाइंस आपको दे रखी हैं 14, तो इसका मतलब जो आपकी नंबर ऑफ फ्लो लाइन 14 दे रखी है, तो 14 - 1 नंबर ऑफ फ्लो चैनल्स डिवाइडेड बाई आपको बेटा इक्विपोटेंशियल लाइन दे रखी है 28, तो यानी ये हो जाएगा 28 माइनस 1, तो ये वैल्यू आ जाएगी 13 डिवाइडेड बाई 27। कितनी वैल्यू आ रही है, ये वैल्यू आ रही है 0.48, लेकिन साहब बोल रहे हैं 0.5, तो इसका मतलब ये ऑप्शन क्या हो जाएगा, दिस ऑप्शन इज फॉल्स। वेरी गुड एक्सप्लेनेशन, very good answer by Shashi and Madhu. Okay, great. Moving forward to the question number 36. Question number 36 का आंसर बताइए। Tell me the answer of question number 36. Tell me the answer of question number 36. When the water flows from a higher permeability region to the lower permeability region through a non-homogeneous section, then the flow lines deflect away from the normal drawn on a non-homogeneous section. When the water flows from high permeability region, suppose if I talk about this is the region, the high permeability region. What does mean by high permeability region? It means suppose the permeability here is K1, K2. So here the permeability K1 is greater than K2. If the permeability K1 is greater than K2, then the water will flow easily. Then the water will flow easily. Then the head loss will be less. When the head loss will be less, it means that this medium is the rarer medium. In this case, this medium will be denser medium as compared to this medium. Now what happens when the water will flow from higher permeability to lower permeability? This is basically the flow line. So when the water will flow from higher permeability to a lower permeability, and this is basically the normal drawn. So this is basically the normal drawn. So what happens when the light flows from when the light flows from rarer medium to denser medium, it will bend. When the light flows from rarer to denser medium, it bends towards the normal. Similar way, when the flow line or when the water flows from rarer medium to denser medium, it will bend towards the normal. It will bend towards the normal. And what he is saying, that it will deflect away from the normal. So this statement is false. This statement would be false. This statement will be false. The correct answer would be B. And if you want to know the formula, so if θ1 is this is the angle made by the normal of the flow line. This is called as θ2. Then the formula for law of permeability is θ1 upon θ2. θ1 upon θ2 will be equal to K1 divided by K2. θ1 divided by θ2 will be equal to K1 divided by K2. So this answer of this question would be B. Moving forward to the question number 37. Tell the answer of question number 37. Tell me the answer of question number 37. The upstream face of a earthen dam is flow line. Tell me whether this statement is true or false. This is suppose for earthen dam. This is for example earthen dam. When we construct the earthen dam, we construct the earthen dam generally. When the foundation is weak. It does not have a tendency to support the gravity dam. So when you make the earthen dam, you will store the water behind it. So what will happen, because of the porous nature of the soil, the water will start floating, the water will start moving through the soil. And in order to catch that water, we make a filter that is called as drainage filter at the base. So water will flow like this. Suppose this is the water will flow like this. The water will flow like this. So these are basically the flow lines. and these lines are called the lines which are perpendicular to the flow lines. So the first equipotential line is what? This is the first equipotential line. If I talk about, this is the first equipotential line, and if I talk about the flow line, so this will be the first flow line. So the shape of this top flow line, is parabolic. The pressure on this top flow line is atmosphere. That's why the top flow line of the earthen dam is also called as phreatic surface. It is also called as phreatic surface. But in the question he is trying to ask, what is the upstream phase? So this is basically the upstream phase. So this upstream phase is not the flow line. This is basically the equipotential line. This is basically the equipotential line. So this statement is absolutely false. Okay, great Shashi, great. So this is the right answer of this question would be B. The right answer of question number 37 will be B. Okay, moving forward to the question number 38. Tell me the answer of this question. Tell me the answer of this question. Tell me the answer of this question. The value of R upon Z at which stresses obtained from the Bosnick theory and the Westergaard theory is 1.5. So if I talk about the Bosnick theory, according to Bosnick theory, sigma b is equal to kb into q by z square. That is kb into q by z square. And if I talk about the stresses by Westergaard theory, then it is equal to kw multiplied by q by z square. If I talk about what is the formula for kb, then the formula for kb is equal to 3 upon 2 pi 1 plus r upon z ka whole square की whole power 5 upon 2. But if I talk about the kw, then the formula for kw is equal to 1 upon pi 1 plus 2 times of r upon z ka whole square की whole power 3 upon, okay, whole power 3 upon 2. So what is saying, what is the value of r upon z when both the stresses are equal? So when you equate both the stresses and do the calculation, then you find when r upon z is approximately equal to 1.5, then the stresses by the Bosnick theory is equal to stresses by Westergaard theory. So this statement is also true. This statement is absolutely true. The answer of question number 38 would be A. Very good, Madhu. Very good, Shashi. Moving forward to the question number 39. Tell me the answer of question number 39. Yeah, exactly it is 1.52. Exactly it is 1.52, but approximately most of the books it is written as 1.50. So we can, yes, base parabola, bilkul right, है ना? So 1.5 is usually taken, and in your exam, if he is saying about 1.5, so you can take it. Question is incomplete. Consolidation through vertical sand drains is the case of 1D consolidation. Question is complete, my dear student. This question is complete. This question is complete. There is nothing remaining in the question. The question is absolutely complete. Sorry, my dear students. Nowadays my health is, I don't know, weather is changing, my health is not, sometimes it happens. The corona is also growing, maybe just because I go outside, and I don't know about it, but from few days I'm not feeling well. So Shashi is saying true. So the question is consolidation through the vertical sand drains. Consolidation through the vertical sand drains is a case of 1D consolidation. This is absolutely true, because when you construct the sand drains, then the flow of water through that sand drains is lateral also. It is lateral also, and it is vertical also. So basically the flow of water The flow of water or the consolidation through the vertical sand drains is example of radial flow and the vertical flow. So it is basically 2D dimension or the case of two-dimensional flow. This statement is false. Consolidation through vertical sand drain is a case of 1D consolidation. False. It is the case of 2D consolidation. Okay. So vertical sand drains is a case of 1D consolidation? No, it is a case of 3D consolidation. Actually, if you see in the 3D, if it is vertical sand drains, then the water will go inside also. The water will go into the sand from outside also. Water will go from X direction also. Water will go from Y direction also. Water will move from Z direction also. So actually, it is not the case of 2D. Actually, it is a case of 3D consolidation. So this consolidation through vertical sand drains is a case of 3D consolidation. It is not the case of 1D or 2D consolidation. So this statement is absolutely false. Okay, no issues, Shashi. So the answer of this question would be B. Okay, moving forward to the question number 40. Tell me the answer of question number 40. Tell me the answer of question number 40. The peak strength of dense sand is always equal to the peak strength of I'm sorry, students, is equal to the peak strength of loose sand. Just see it. If you saw about the stress strain curve about the loose sand and dense sand, अगर आप बेटा लूज सैंड्स और डेंस सैंड्स के बीच का स्ट्रेस स्ट्रेन कर्व देखेंगे तो कैसा मिलता है, आपने पढ़ा भी होगा. देखिए ये जो कर्व मिलता है, अगर हम डेंस सैंड की बात करें, क्योंकि डेंस सैंड एक वर्क सॉफ्टनिंग सॉइल होती है, तो कर्व कुछ ऐसा मिलता है, और लूज सैंड एक वर्क हार्डनिंग सॉइल होती है, तो कर्व कुछ कैसा मिलता है, ऐसा मिलता है. So this is basically the curve. This curve is of dense sand and this curve is of loose sand. So this is called as peak strength of dense sand, and this is basically the peak strength as well as ultimate strength of loose sand. And this is also called as this is also called as the ultimate strength of dense sand. This point indicates, this lower point indicates the ultimate strength of the dense sand. This point indicates the ultimate strength, peak strength of the dense sand, and this point will indicate the ultimate strength as well as peak strength of the loose sand. What is trying to say? The peak strength of dense sand is always equal to the peak strength of loose sand. It will never be possible that the peak strength of dense sand can becomes equal to the peak strength of loose sand. This is basically the peak strength of the dense sand, and this is basically the peak strength of loose sand. So that can never be possible. This statement is false. So 40 का आंसर हो जाएगा B. Thank you so much, beta. Thank you so much, Shashi. Moving forward to the question number 41. Tell me the answer of question number 41. Tell me the answer of question number 41. नेक्स्ट क्वेश्चन का आंसर बताएंगे सब लोग. 41 का ए बता रहे हैं. 41 का ए क्या बता रहे हैं? दैट द अल्टीमेट स्ट्रेंथ ऑफ डेंस सैंड इज ऑलवेज इक्वल टू लूज सैंड. देखिए अगर पिछला वाला डायग्राम देखें तो आप यहां पर देख रहे हैं साफ कि जो लूज सैंड की अल्टीमेट स्ट्रेंथ है वही उसकी पीक स्ट्रेंथ है, और अगर हम डेंस सैंड की बेटा अल्टीमेट स्ट्रेंथ की बात करें वो भी बेटा लूज सैंड से बिल्कुल मर्ज कर रही है. तो बेटा एक डेंस सैंड की पीक स्ट्रेंथ एक लूज सैंड की पीक स्ट्रेंथ से तो हमेशा ज्यादा होती है, लेकिन डेंस सैंड की लूज स्ट्रेंथ और डेंस सैंड की अल्टीमेट स्ट्रेंथ और लूज सेंड की अल्टीमेट स्ट्रेंथ हमेशा क्या होती है, बराबर होती है. तो दिस स्टेटमेंट इज एब्सोल्युटली ट्रू. This statement is absolutely true. The answer of question number 41 will be A. Moving forward to the question number 42. Moving forward to the question number 42. Pole or the origin of planes is a unique point on the Mohr circle. Tell me whether this statement is true or false. Okay, moving forward to the answer of this question. Let me check how many I have. 42 का A. Yes, this point is a unique point on the Mohr circle. Circumference का वो point होता है जिसकी मदद से हम किसी और point या किसी और plane के stresses निकाल लेते हैं. The right answer of question number 42 would be A. True. Moving forward to the question number 43. Tell me the answer of question number 43. Tell me the answer of question number 43. The angle of obliquity is the angle which the resultant of normal stress and shear stress makes with the normal axis of the plane at which the stress are acting. Tell me the answer of this question. Tell me the answer of this question. Angle of obliquity is the angle which the resultant of normal stress and shear stress makes with the normal axis of the plane at which stresses are acting. So what he is trying to say that the angle of obliquity, suppose this is the plane. So कह रहा है angle of obliquity क्या होती है, किसी भी plane पे लगने वाला normal stress. Suppose this is basically the shear stress and suppose this is basically the normal stress. Angle of obliquity is basically the resultant of normal stress, angle which the resultant, so suppose this is the resultant of stress, the resultant makes with the normal axis of the plane. So this is basically the angle of obliquity and this statement is true. Okay, yeah, the answer of 43 is true. This statement is absolutely true. Shashi is saying, can you explain the question number 42 by diagram? Yes, I can explain this by the diagram. What do you mean by the poles or the origin of planes? What do you mean by? So the answer of question number 43 is absolutely true. Shashi is saying, explain the question number 42 with the diagram. Let me check. Let me tell you what do you mean by the poles or the origin of poles. Just see. Suppose for example, this is basically, this is an element and this is subjected to certain forces. This is subjected to shear stresses tau xy. This is subjected to shear stresses tau xy. This is subjected to shear stress tau xy. This is subjected to shear stress tau xy. And it is also subjected to sigma x, sigma y, sigma y, sigma x and sigma y. So how we determine the pole? So pole एक ऐसा unique point होता है. Pole is the point through which if I passes a line, suppose pole is a point through which if I passes a line at an angle of theta, then this line will intersect the Mohr circle at any point. This line will intersect the Mohr circle at any point. The point at which the line which is drawn at an inclination of theta cuts the Mohr circle gives the some stresses that sigma comma tau. So those stresses which are given by the line which is cutted by this inclination theta, which is drawn at an inclination theta. So the inclination of the line which is drawn, which is passes through the pole, is suppose theta. It will cut the Mohr circle at a point sigma comma tau. The inclination of these stresses on the actual plane will also be theta. The inclination of these stresses, if these stresses on which they act, it's also be theta. So this is sigma comma tau will be acting on this plane. So what I'm trying to say, that pole is basically that unique point through which if I passes a line, then the slope of that line will be the same as the slope of the plane on which the stresses sigma comma tau acts, which are obtained by the intersection of line with the Mohr circle. This is called as pole. So if I know the stresses of any plane, so what we do, if I know the stresses of any plane, and if I draw the line at an angle of theta, then that line will cut. If I think in the reverse manner, suppose if you know the stresses at any point, and those stresses are actually acting on theta on the main plane, on the actual plane. So if I draw a line at an inclination of theta, then the point at which that line cuts the Mohr circle is called as pole. Suppose for example, if I draw the Mohr circle. These stresses are sigma x comma tau xy, sigma x comma tau xy. So somewhere sigma x comma tau xy is here, somewhere sigma y and tau xy will be here. So the Mohr circle would be like this. This will be the Mohr circle. Got it? This is basically the center. Now what happens? This is the stresses you know already. And these are the stresses you know already. And you know also on what plane these stresses are acting. Suppose now we want to find the pole. So first we know that sigma x and tau x is acting on this plane. So if I talk about on what angle these stresses are acting, then you will say it is acting on a plane which is at an angle of 90 degree with the horizontal. You will say that sigma x and tau xy are acting on a plane which are at 90 degree to the with the horizontal. So what I will do, I will draw a line. So this is horizontal axis. I will draw a line at an angle of 90 degree. So this is basically the line I draw at an angle of 90 degree. It will cut at certain point, and this point is nothing but called as pole. If you don't want to learn from this concept, just see these stresses. You know also about sigma x, sigma y and tau xy. And as you see, this sigma x and tau y are acting on a plane which is at an angle of 0 degree with horizontal. So what will do? You will go at this point, draw a horizontal line, and draw a line with the horizontal at an angle of 0 degree. So when you draw a line at an angle of 0 degree, horizontal line at an angle of 0 degree, so you will see it will intersect at this point. So this point is basically the pole. The pole is basically the unique point through which you can determine the stresses. Now if you want to find the stresses, suppose this is horizontal. Now if you want to find the stresses on the plane which is at an angle of 60 degree, actually, so what you will do, from the pole you will draw a line. At an angle of 60 degree. When you draw a line at an angle of 60 degree, it will intersect at the some point. So these are the stresses on the plane of 60 degree. So basically pole is basically the unique point, and this method by which you determine the pole is called as pole method. So by using the concept of pole or the origin of pole, we can determine the shear and normal stresses on all the planes. Okay, so I hope you understand. Moving forward to the question number 44. Tell me the answer of question number 44. Tell me the answer of question number 44. So what is this question? Just see it. The drain shear strength is used to evaluate the long-term stability of any structure. Is used to evaluate the long-term stability of any structure. Tell me whether this statement is true and false. There are two types of strength. The one is called as drain shear strength and another is called as undrained shear strength. So we say that the undrained shear strength in the clay soils generally happen in the long term. When we apply the load, then an excess pore pressure will develop, and in the long term, that excess pore water pressure will get dissipated. So the drained condition will set up in the long term, and undrained condition will set up in the short term. So that's why we will say the long term, that's why we will say the drain shear strength will evaluate the long term stability of any structure, and undrained shear strength is used to evaluate the short term stability of any structure. So the right answer of this question would be true. Oh, the right answer of this question would be true. Very good, Madhu. Very good, Vikas. Very good, Vikas. Okay, moving forward to the question number 45. Tell me the answer of question number 45. Tell me the answer of question number 45. In normally consolidated clay behaves like a slurry at zero effective stress. In normally consolidated clay or normally कोई बात नहीं बेटा, अगर मैं जब बेटा पूरा सॉइल मैकेनिक्स पढ़ाऊंगा मैं, ठीक है, आई एम स्टार्टिंग द फुल सॉइल मैकेनिक्स, तो जब मैं फुल सॉइल मैकेनिक्स कवर करूंगा तो आपको बेटा मैं अच्छे से कराऊंगा. अभी तक मैंने मैराथन्स के थ्रू सॉइल मैकेनिक्स कवर किया है, अब मैं नॉर्मल लेक्चर्स के थ्रू प्लान कर रहा हूं सॉइल मैकेनिक्स, हाईवे इंजीनियरिंग या आरसीसी, तीन में से एक सब्जेक्ट बहुत अच्छी क्वालिटी में यूट्यूब पर पढ़ाऊंगा फ्री ऑफ कॉस्ट. तो बेटा आपको बहुत सारे सब्जेक्ट्स की क्लियरिटी पता चलेगी. Very good. Normally consolidated soil have never been subjected to any stresses in the future. जब उसने अपनी हिस्ट्री में कोई स्ट्रेसेस भी बर्दाश्त नहीं किए हैं तो वो कंसोलिडेटेड नहीं हुई है. जब कंसोलिडेट ही नहीं हुई है तो उसके अंदर स्ट्रेंथ ही डेवलप नहीं हुई है, और जब उसके अंदर स्ट्रेंथ ही डेवलप नहीं हुई है तो जीरो इफेक्टिव स्ट्रेस में तो वो स्लरी की तरह बिहेव करेगी ही करेगी. तो राइट आंसर ऑफ दिस क्वेश्चन वुड बी ए. दिस स्टेटमेंट इज एब्सोल्युटली true. Moving forward to the question number 46. Okay, this is very nice. Moving forward to the question number 46. Tell me the answer of question number 46. Tell me the answer of question number 46. In a vein shear test, the shear stress distribution at the time of failure is parabolic along the diameter and linear along the length. Linear along the length. So you need to answer this question. So this is basically the veins. These are basically the veins. These are basically the veins. Okay, so I will try to tell you what is the shear stress distribution. Meanwhile, you can answer it also. So this is the axis of the shaft or the axis of the shaft which we insert. Uniform along the length and triangular on the top and bottom plates. So just listen it. Just listen it, my dear student. If I talk about the actual shear stress distribution, so what happens? The actual shear stress distribution would be like this. Actual shear stress distribution will be like this. It is basically the linear or constant along the along the edges, along the length, it is basically this. But if I talk about the diameter, then it is parabolic. If I talk about the diameter, this is all about actual shear stress distribution in the vein shear test. This is basically the actual shear stress distribution in the vein shear test. Actual shear stress distribution in the vein shear test. So what happens as you apply the torque, initially this fiber will fail. Initially the outermost fiber will fail. The shear stress in this outermost fiber will reaches to the shear strength of the soil. This fiber will reach first, but as you apply the torque, then the another particle inside layer, it also increases, the shear stress increases, and the inside fiber will also reaches to the maximum stress. So what happens at the time of failure, all the fibers all the fibers are subjected to a stress called as failure stress or the shear strength of the soil. That's why at the verge of failure, if you see at the time of failure, all the fibers will get subjected to the failure. So at the time of failure, you will see that the linear distribution along the length, and also the linear distribution or uniform distribution along the diameter. So this is all about the when all the fibers are reaches their maximum limit, then the soil is at the verge of failure. And this is the case when the soil is at failure. So basically this statement is absolutely wrong, because the actual distribution will be like this, and we assume in the soil mechanics, as the Shashi was saying, that it is linear along the length and it is triangular along the diameter. In the soil, in case of SOM, we assume this parabolic curve is to be triangular. Because we have studied tau by r is equal to t by j. So tau is directly proportional to radius. We assume it to be linear. We assume it to be linear only when the material is homogeneous, isotropic and elastic. But since the soil is not homogeneous, soil is not elastic, so the actual shear stress distribution comes out to be parabolic around the diameter and linear along the length. And that is when the soil is not failed. But when the soil is at the verge of failure, then all the fibers will get subjected to the stress equal to tau f. Then a linear distribution will be obtained both on the diameter and both on the linear. So this statement will be true. This statement would be false. That is the option number B. I hope you have understand some things. I hope you have understand some new things. Moving forward to the next question. This is the question number 47. Tell me the answer of question number 47. No. In the derivation, we assume the constant, we assume the linear also. In the derivation, we assume the linear. In the derivation, you see, if you assume the linear, beta, you assume a linear element at a distance of r. So if you assume it linear, then the stresses here are different, here are different, here are different, here are different. But while doing derivation, suppose if you are saying we assume it to be linear, just let me tell you, suppose for example this is the circular part, and if you assume to be linear, and what you do, as the radius is changing, so at a distance r, you assume a dr element, So if I talk about what are the stresses at this point, if I talk about the torque, so you will write the torque is equal to force into perpendicular distance. So what is force? Force is equal to shear stress, and you assume the shear stress is not to be the shear stress at this point. You assume the shear stress is to be tau f. multiplied by 2 pi r into dr and multiplied by the distance r. So you understand, at a radial distance r, when you assume an element dr, we assume the stresses as to be tau f. If you assume it to be linear, then it means at a distance r you have to be assume the shear stress to be tau r. But actually we have assumed these stresses to be linear, because at the verge of failure, at the time of failure, all the fibers will be subjected to the same shear stress, that is called as tau f. Just see, yeah, we will assume the ring. Yeah, I'm just driving it. So if you take a radial distance, the shear stress will be tau f only. Because if you don't take the tau f, then how you determine it? So because at every radial distance you are getting the different shear stress. So if you use this radial distance, so you need the shear stress of this point. Did you do like this? No, you just assume the shear stress to be linear, and it will be linear because we do the analysis when the soil is at the verge of failure. I hope, Shashi, you have understand this concept. Whether this concept is clear or not. While doing derivation, we assume that the distribution is linear. We assume the distribution is linear. We don't assume the distribution is triangular. Whether this concept is clear or not, Sashi? Just tell me first. Okay, no issues. Thank you so much. Okay, this is the question number 47. Just tell me the question number 47. Just tell me the question number 47. Question number 47. When the dense sand is tested in an undrained and the drained condition, then the shear strength in the undrained condition would be greater than the shear strength in the drained condition. Tell me whether the statement is true or false. Tell me the answer of question number 47. (47B). देखिए, when we test the sand in the undrained condition, so the dams have a tendency to develop a negative axis pore water pressure. When we test the sand, suppose this is the dense sand and this is also a dense sand. There are two cases when the sand is tested. When the sand is tested in undrained condition and when the sand is tested in the drained condition. So what will happen in the undrained condition? In negative axis pore water pressure will develop. In case of drained condition, zero, matlab no axis pore water pressure will develop. So you determine the effective stress. When the negative axis pore water pressure will develop, then effective stress is equal to total stress minus pore water pressure. Then the effective stress in the undrained condition will comes out to be greater than effective stress in the drained condition. Yes or no? Effective stress in undrained condition would comes out to be the effective stress in the undrained condition. So in this case, when the soil is tested in the undrained condition, the effective stress comes out to be more. So the dense sand will give more shear strength in the undrained condition as compared to the drained condition because of negative axis pore water pressure in the undrained condition. So this statement is true. The answer of question number 47 is A. No beta, no. No beta, no. In the drained condition, The shear strength is will be more as compared to, if I talk about the loose sand. If I talk about the loose sand, then in case of loose sand, undrained shear strength will be less than the drained shear strength. But in case of the dense sand, undrained shear strength would be greater than the drained shear strength. You are listening? If I talk about the loose sands, just I am explaining it. Suppose there are loose sands, there are two loose sands. There is one loose sand and there is another loose sand, and the first loose sand is subjected to undrained condition, and the second loose sand is subjected to drained condition. So in case of loose sand, a positive axis pore water pressure will develop. If the positive axis pore water pressure will develop, then the effective stress will be equal to decreases because of this positive value. But in case of drain condition, effective stress will be equal to total stress. So here you can see you have to be subtract u from this. So what will happen? The effective stress in undrained condition will comes out to be effective stress in drain condition. So the shear strength in undrained condition will be lesser than the drain condition in case of loose sand. Does not happen in case of dense sand. So this statement is absolutely true. The answer of question number 47 is A. A is the correct option. Moving forward to the question number 48. Tell me the answer of question number 48. Tell me the answer of question number 48. What he's trying to say, liquefaction is due to critical hydraulic gradient. No, liquefaction is not due to critical hydraulic gradient. Liquefaction is basically due to the positive axis pore water pressure, developed in the loose saturated soils, sands. In case of loose saturated sands, due to the generation of high positive pore water pressure, the effective stress becomes zero, due to which the soil loses all of its shear strength and starts flowing like a water, and this phenomena is called as liquefaction. So the right answer of question number 48 is, the right answer of question number 48 would be B. Moving forward to the question number 49. Moving forward to the question number 49. Tell me the answer of question number 49. The active earth pressure obtained from the Rankine theory is greater than the Coulomb theory. The active earth pressure obtained from the Rankine theory is greater than the Coulomb theory. Tell me whether this statement is true or false. Yes, this statement is absolutely true. The active earth pressure obtained from the Rankine theory is greater than the active earth pressure obtained from the Coulomb theory. That is because the Rankine have neglected the friction. That is because the Rankine have neglected the friction. That is only because the Rankine have neglected the friction. This is the only reason, and this is the only reason that the Rankine theory is simple. It will give the higher active earth pressure as compared to Coulomb theory, and this is the only reason, as we know that the retaining walls are designed for active state, and this is the only reason that in India the retaining walls are designed by Rankine theory, just because the Rankine theory give the conservative results. The safe design will be happen by the Rankine theory. So this statement is true. The answer of question number 49 would be true. This is the last question of today's class. Tell me the answer. This is the last question for today's class. What he's trying to say is trying to say the shape factors for the circular footing are 1.3 and 0.1. Whether this statement is true or false, this statement is absolutely true. For the circular footing, the shape factor alpha 1 is equal to 1.3 and the shape factor alpha 2 is equal to 0.3. This statement is absolutely true. The answer of question number 50 is A. The answer of question number 50 is A. I hope you understand, you have learned various things using this concept. Okay, so let's over this class at this point. Thank you so much, my dear student. Keep learning, keep rising, keep growing.